Hello, everyone. We're going to be looking at a topic which is approximation, and I have my slide here, and we're going to be explaining through this slide. So, approximations are the exact number of figures, and we can denote the sign as this. Another approximation will still make use of uh, words, figures in words. That is, we can make use of when we are writing in thousands, we write in hundred, we are writing in tens, and we write in units. And when we have decimal point, it changes from the lowest to the highest. So we have an example here. If you look at this, this is 4 digits, so this should be rated in thousands. And since we are having this in decimal point, this should be rated in cents. So we are starting with cents instead of units based on the fact that we have the decimal point. So let's pick and let's see how it goes. So this one will be in thousands because it's in 4 digits. The next one is 100 because we have 3 digits. The next one should be in 10, and the next one should be in units. Now we start from tens. We have our tens, we have our 100, and we have our thousand. So with that, let's check. Yeah, I think it's right. So we go to the next one, which is rounding up. Under rounding up, we can round up values that are below 4 to be zeros, and we round up values that are above 4, which is 5 upward, to be 1. So if that is it, then let's look at examples that we have here. We have this number here, which is 38,728 people attend a mathematics class. So we have to round up this value to the nearest one, into the nearest 100, 10, 1,000, and 10,000. So we have these two examples there for us to do. So if you round this up to the nearest 10, we are picking just only the last value. We round the last value up to 1 because it is more than what? 5, and the value turns to 0. So we can have our answer to be this. Okay, now let's look at what we have in 1,000s. We are picking the last three values because we have three zeros there. So if you round this up, this gives 1, make this one 3, and by the time you round this one up, it gives 0, and make this one intact. So nothing is happening to 7 because this is 0 and it's not adding. But now if you round up 7, it will give us 1, and 7 will become 0. So if you add that one to 8, it will give us 9. So we have 39,000. So we have already run the other two subs, and we have the next slide. So if you look at this, we want to round up 38 to the nearest 10, 2,094 to the nearest 100, and 74,245 to the nearest 1,000. So if we round this, we take the last value, and that's turned to 0. So we have our answer to be 80. If you round this up, we are taking the last two digits since it's in 200. So this turns to 0, and we don't have any other value. And this turns to 0, but we have 1. Why? Because it's more than 4. So it gives 1 by the time you round up, and by the time you add it up, this is 10. You can't leave it as 10 because 10, by the time you are pronouncing it, it is not giving any accurate information. So you round 10 up again to 1 and add it to 2. So this gives 3. So we have this to be 3,000. And by the time we write this one to the nearest 1,000, this gives 1. Add it to this, it makes 5. So we can round this up again, it gives 1. By the time you add it to this one, it gives 3. But 3 will not give any value because it's what? It's less than 5. So we come to this, and since it is to the nearest 1,000, our answer is going to give us 74,000. So let's check. So we are good to go. So let's look at the next one here. We can try to do this. Let's fill in the gap. We round this up to the nearest 10, 36 to the nearest 10. It gives 40. Why? Because 6 is more than 4 and it gives 1. If you round this up, it gives 7,000. By the time you round it up, okay, 7,000. Why is it giving 7,000? This becomes 1. It makes this 6. By the time you add 6 to this one, it makes it what? 9. So you can try to round 9 up again, and that 9 gives 1. By the time you add up here, it gives what? 7. So we have this to be 7,000. So we can check this as well. So we check this. Okay, now if you round up this to the nearest thousands, so this zero zero, we can't do anything with this. But if you round five, five will give us one and make this 10. We can't leave it as 10, so we have to round up again. So if we round 10 up, it will give us one. So I believe by the time we round up, it gives one. Add it to this one, that's 10. So this will give us 10,000, which we are good to go. Now let's look at another one. For this one, let's round up quickly to the nearest 10. It will give us 60. If you round 57 to the nearest 10, it gives 60 because 7 becomes 1. Now, 44,544, if you round up to the nearest 1,000, it gives what? 4,500 because this is 0, this is also 0. 34,567, if you round it to the nearest 1,000, it should give us 35,000 because by the time you round up and you get to 5, 5 will becomes 1 and adding up to 4 will give another 5. And by the time you round this one to the nearest 10,000, it should give us 4, becomes 0. This is 5, 1. By the time you put 5 here, it is to still make this 0, to make this 0. So we have this to be our answer. So let's check. I think we are right. So let's go to the next one. Now, this is decimal place. Any value, as I said earlier, that is below 4, you round it up to 0, and any value that is above 4, which is 5 upward, we round it up to 1. And decimal place rather, indicate the number of times that a natural number can be approximated. And this point here, we call it decimal point. So we use this to check an activities here. We want to round up to 2 decimal places. So that implies that for us to have 2 decimal places, we have to round up after the decimal point in 2 places. 3 will become 0 and we can have this. So if you round that up, it will give us 8.85. And if you look at this, this is to 3 decimal places. That implies that after the decimal point, we can only have 3 figures because we are rounding up to what? 3 decimal places. So by the time we round that up, it will give us 0.054. So let's check. So I think we are right. So let's look at the next one here, which is significant figure. One thing about significant figure is it doesn't deal with the points, and zeros value before the decimal point are non-significant, but zero values after the decimal point after the non-zero numbers are actually significant. So whenever we are dealing with this, we are not interested in all these values because they are not significant to us. So if you have to approximate zeros before any non-given zero digits rather are not significant, while zero values after the non-zero digits are significant. So with this, let's go and see to the next one. So let's look at it. We have upper boundary and lower boundary here. Let's use it to explain. Now, if you look at this one, 4.4, the lower value of 4.5 here is 4.45 because this one, by the time you approximate 4.45, if you approximate it to like 1 decimal places, it will give us 4.55. And for this one as well, 4.55 is actually the lower boundary to 4.6 and upper boundary to 4.5. By the time you round up 4.55, this will give us 4.6 because 5 becomes 1. Adding to 5, we have 6. So now let's look at, we have an activities here. This activities is telling us that let's see what happens by the time we are rounding up to significant figures. So we are trying to estimate this. So let's see, if you have 68 multiplied by 257, let's approximate this one to the nearest 2 digits. 8 becomes 1, add to 6, that is 7, so you make this 70. And this one, by the time you round this up, you add, this becomes 1, add to 5, that is 6. Round up 6 again, it makes it to be 0 and becomes 1. You add to 2, that is 3. So by the time you multiply this, let's multiply 70 multiplied by 360, we can have 21,000. So this is the first way of first attempt to this solution. We can decide to round up again to one significant figure. So if you decide to round up to one significant figure, this becomes 70. But if you round this up to one significant figure, this becomes 0 and 7 becomes 1. Add that one up to 5, it gives 6. So this makes 260. So by the time you multiply 760 times 260, then we have this answer. Let's check. So if we have that answer, that these are the two possible ways where we can actually solve this type of question. So we are good to go. And let's look at another example here. We want to round this up to three significant figure. We round this up to two significant figure. We round this up to one significant figure. As I told us earlier, that under significant figure, points are not to be put into consideration. So you round up based on the figure. So you read the numbers of figures that we have to do. Now, for this as well, points is not going to give us any significant value. We are dealing with the number. So since we have that, so we are dealing with the numbers. The 0 is of no value to us. Now, for this first one, we round to three significant figure. This now will become what? 1. Add it to this, that make it 6. So we have this to be 37.5. Why? By the time you round, this is the first time, you round up to this place, make it 6. Round 6 up to 4, that will give us 5. So we have that 7.5. Now let's look at this one, 0.056. Round it up to two significant figure. The zeros are of no use, so we don't need it. We are dealing with the important values after the zeros. So which is a non-zero digit. Round 2 up, it will give 0. Round 6 up, it will give 1. So if you round 6 up, it will give 1, but nevertheless, we are not using that. So what we are dealing with here is we are rounding up 2. So by the time you round up 2, it will give what? It will give 0. So the significance after these zeros is 5 and 6. So we have this. And the last one we have here, we are rounding this to nearest one significant figure. So 6, we give 1, we add to this, that is 5. Add 1 again. By the time you approximate 5 to this, that is 1 plus 4, that is 5. So since it's 5, we have to round up again because we are dealing with one significant figure. So by the time we round 5 up, it gives 1, and this makes 8. We are dealing with one significant figure, so we need a significant value that is just 1, that is significant. So this 8 again, we have to round up, and that makes 40. So we can drag this and let's check. So which is cool. I think you are right. Now let's go to the next one. This is examples on our own. We want to estimate this. Let's just estimate and see. When you estimate 2 raised to power 5, that is 32, right? So if you approximate 32 to the nearest one decimal place, it can give us what? 30. So 2 raised to power 5 is 32. That is 2 in 5 places. Now the 4 cube or root of 600. By the time you know, but this is not possible, so we look at the possible value that is possible, which is 625. So by the time you have 625, 4 root of 625 will give us what? I think it should give us 5. That is 4 in 5 places. Sorry, 5 in 4 places rather. So if we have that, now we can multiply through. So we have this answer here to be 30, and we have this one to be what? 5. So 30 times 5 will give what? 150. So we have 150. Now if you divide 150 by, okay, if you divide 150, let's divide 150 by 8. So if you divide 150 by 8, our answer is what? 20. So we have 20 as our final answer here. So 20 makes our final answer. So we check, and I think the arrangement is right. And that leads us to past questions. We have past questions here. The first one is telling us that an athlete's time for a race was 43.8 seconds. So we have to write the time correctly to one decimal place and one significant figure. So for one decimal place, the point is very important. So we round this up just once, and by the time we round 8 up, it gives 1. 1 plus 7 will give 8. So our answer is going to be 43.78. So we have 43.78. Now, to one significant figure, I've told us before that we don't need the point. So the significant point is of no value. So what we need is we need significant numbers. Numbers that are very, very significant. So by the time we round this up to 7, it makes it 8. You can round 8 up as well to 3, that make it 4. So and 4, any value that is less than 4, I said, that is less than 5, we give 0. So since we have 4, so 4 will give 0, and our answer is going to be what? 40. So let's check 40. So that is the answer. Let's check. Okay, now let's go to the next one here. We have to round this up. We have 9876. That's 9,876. Let's round this up to the nearest 1,000. So by the time you round this up, this will give 1. Add 1 to 7, that's 8. Round 8 up, it gives 1. Add it to this, that is what? 9. As I said, you can't leave it that way because it is the nearest 1,000s, 3 zeros. So round the 9 up to 1, and that makes that 90. Then when you have 1 plus the 9 that we have 10. So our answer is going to be what? 10,000. Now let's check 10,000. So let's look at the next slide here. The next slide there is telling us that our next topic is going to be calculation and order. We want you to subscribe for the full interactive content of this topic in our website, which is www.edubbey.com. Thanks for listening.